Dear students, today we discuss about a new chapter, three-dimensional coordinate geometry. Three-dimensional coordinate geometry. It is a extension of two-dimensional geometry. That is a two-dimensional geometry. In two-dimensional geometry, you have already studied from standard 7 onwards, like there are two axes, x-axis and the y-axis. They intersect. These two axes are perpendicular to each other and they intersect at the point O, and that will be the origin. Origin is taken as 0, 0. Now, when these two points intersect, when these two lines intersect at the origin, you get four quadrants. You get four quadrants. That is, in the plane of the board, the x-axis and the y-axis, they create four quadrants, namely the first quadrant, the second quadrant, the third quadrant, and the fourth quadrant. And in these quadrants, suppose if a point lies in the first quadrant, what is the criteria or what is the property that we have already seen? In the first quadrant, the x coordinate is positive, y coordinate is positive for the point. That is, it will be in the form of 2, 3. When you come to the second quadrant, you can see that OX dash is negative. OX dash is negative. That means x coordinate is negative. X coordinate is negative and y coordinate is positive. So the point takes a form -2, 3. And when you come to the third quadrant, the x-axis, OX dash and OY dash are negative. So both x coordinate and y coordinate are negative. And you can see that the points takes a form -2, -3. And when you come to the fourth quadrant, you can see that x-axis is positive, OX is positive, OY dash is negative. That is positive, negative. That is 2, -3. So this is what you have studied in considering two-dimensional geometry. That is, the x-axis and the y-axis divides the plane of the paper or divides the plane of the board into four quadrants, namely OX dash, OX, OY determine the XY plane. This determines X dash Y plane and X dash Y dash plane and XY dash plane. And there are four quadrants. And you know the properties of each quadrant. What will be the criteria for the sign? Criteria for the sign in each quadrant. Criteria for the sign of the points in each quadrant. Now, when you consider the x-axis, the equation to the x-axis is y is equal to 0. And equation to the y-axis is x is equal to 0. X is equal to 0. Equation to the x-axis is y is equal to 0. That is, all points on the x-axis, the y coordinate is equal to 0, and all points on the y-axis, the x coordinate is equal to 0. Now, keeping in mind the two-dimensional geometry, we are going to discuss about a three-dimensional coordinate geometry. Now, we require this in vector geometry that we will study in grade 12. Now, what do you mean by a three-dimensional geometry? Three-dimensional geometry means you have three planes, and in these three planes, they intersect each other at a particular point. Now, this is the XO X dash plane. This is the XO X dash plane. Now, we have YO Y dash plane, and then we have the ZO Z dash plane. ZO Z dash plane. They all intersect at a point, and the coordinate of the point is equal to the 3 dimensions. So it will be 0, 0, 0. Now, when you consider the x-axis, x o x dash, y o y dash, z o z dash. This is the coordinate system, three-dimensional coordinate system. And when you consider the x o x dash, in x o x dash, the y coordinate and z coordinate is equal to 0. That is why, and it is known as the xy plane. A point in the xz plane is y coordinate is 0. And in three-dimensional geometry, a point on the x-axis, its y coordinate and z coordinate is equal to 0. That is, a point on the y-axis, x coordinate, z coordinate is equal to 0. A point on the z axis, x coordinate and y coordinate is equal to 0. Now, because of these three planes, we can see that these three planes divide the space into 8 octants. That is, in two-dimensional geometry, the two lines, x-axis and the y-axis, divides the plane of the board into 4 quadrants. In such a manner, in three-dimensional geometry, the three planes divide the space into 8 octants. 1, 2, 3, 4, 5, 6, 7, 8. It divides the space into 8 octants. Now, in the first octant, that is, here it is a OX, OX dash, OY, OY dash, OZ, OZ dash. Now, in the first octant, XOY, in the first octant, XOY, we can say that x coordinate is positive, y coordinate is positive, z coordinate is also positive. So, we can say that in the first octant, x is positive, y is positive, z is positive. X is positive, y is positive and z is positive. When you come to the second octant, x is negative because this is xo x dash. This is negative, y is positive and z is positive. So, second one, x is negative, y is positive and z is positive. And when you come to the third octant, this is x dash. This is negative, y is negative and z is positive. And when it comes to the fourth octant, you can see that x is positive, y is negative and z is positive. So, this is about the 4 octants. Now, when you come to the fifth octant, what about the fifth octant? Now, you can say that in the fifth octant, this is the fifth octant. X coordinate is positive, y coordinate is positive and z coordinate is negative. In the fifth one, x coordinate is positive, y coordinate is positive and z coordinate is negative because it is downwards. Now, in the sixth octant, what about the x coordinate? X coordinate is negative, y coordinate is positive, z coordinate is negative. And in the seventh one, x coordinate is negative, y coordinate is negative and z coordinate is also negative. And in the eighth octant, you can see that x coordinate is positive, y coordinate is negative and z coordinate is negative. So, this is how a three-dimensional geometry, the space is divided into. The space is divided into 8 octants. Whereas in two-dimensional geometry, the plane of the board or the plane of the paper is divided into 4 quadrants. Now, when you consider a point in the x-axis, in 3-dimensional geometry, a point on the x-axis, this is the x-axis, a point on the x-axis, its y-coordinate and z-coordinate are 0. Similarly, a point, so it will be in the form of x 0, 0. A point on the y-axis, what can you say about a point on the y-axis? Its x-coordinate and z-coordinate will be equal to 0. A point on the y-axis, x-coordinate and z-coordinate will be equal to 0. And a point on the z-axis, x-coordinate, y-coordinate 0, you have only the z-coordinate. A point in the xz plane. Now, how do you get the xz plane? X-axis and the z-axis together determine the xz plane. A point in the xz plane, its y-coordinate is equal to 0. A point in the xz plane, that is xz plane, y-coordinate is equal to 0. Now, when you consider the point, you can get a one-word question like this. 1, 2, 3. In which quadrant does it lie? 1, 2, 3. X is positive, Y is positive, Z is positive. That means it lies in the first quadrant. Suppose you have a point 4, minus 2, 3. That is X is positive, Y is negative, Z is positive. That means it lies in the fourth quadrant. The x-axis and the y-axis taken together determine a plane known as the xy plane, and a point on this plane is of the form xy0. The x-axis and the y-axis together determine a plane, and that plane is known as the xy plane. And in the xy plane, a point on the xy plane, its z-coordinate is equal to 0. So that is, it is in the form of x comma y comma 0. I hope you understood this concept. 3-dimensional geometry, that is the 3 planes intersect at a point, and the intersecting point is known as the origin, and this point will be in space, and the coordinates of the point will be 0, 0, 0. And these 3 planes divides the space into 8 octants. 8 octants. 8 octants. 8 octants. And you can make a model of this form and you can easily identify, so that it will remain in your mind forever. X dash, X O, X dash, Y O, Y dash, Z O, Z dash. So, see, 8 octants. 1, 2, 3, 4, 5, 6, 7 and 1, 8. This is the 3-dimensional geometry. 3-dimensional geometry. Now, here you have to study 2 concepts, that is the distance between. I hope all of you have understood this one. Now, here you have to study 2 concepts, distance between 2 points in space. In space, when you consider a point in space, it will have x coordinate, y coordinate and z coordinate. Now, the first one is known as the distance formula. Suppose if there are 2 points, x1, y1, z1, x2, y2, z2 and x3, y3, z3. Because it is a point in space. What is the distance formula? The distance d is equal to root of x2 minus x1 the whole squared plus y2 minus y1 the whole squared plus z2 minus z1 the whole squared. There are 2 points, and what is the distance between them? Let us consider the 2 points P, x1, y1, z1, Q, x2, y2, z2. What is the distance between these 2 points? It is d is equal to root of x2 minus x1 the whole square plus y2 minus y1 the whole square plus z2 minus z1 the whole square. Now, where do you use this formula? Now, suppose you have to show that the 3 points are collinear. 3 points are collinear. 3 points are collinear. We make use of this formula. Now, next one, to prove that a given triangle is isosceles or equilateral. A quadrilateral is a parallelogram or a rectangle. Also used in right triangle. So these are the familiar questions you may get. Where do we use the distance formula between 2 points x1, y1, z1? These 2 points are in space. x1, y1, z1 is a space. x2, y2, z2 is a point in space. What is the distance between these 2 points? It is given by root of x2 minus x1 the whole square plus y2 minus y1 the whole square plus z2 minus z1 the whole square. And these the application of this formula is to show that the 3 points are collinear, to prove that a given triangle is isosceles, equilateral or a right triangle, to prove that a given quadrilateral is a parallelogram or a rectangle. This we will discuss in detail. Now take down. Find the distance between the points. Find the distance between the points. The distance between the points minus 372 and 2, 4, minus 1. You can take this as x1, y1, z1 and this as x2, y2, z2. What is the distance between these 2 points? Write the formula. Distance d is equal to root of x2 minus x1 the whole squared plus y2 minus y1 the whole squared plus z2 minus z1 the whole squared. The distance is always taken as positive. So this is equal to root of x2 minus x1. 2 minus 3 the whole squared plus 4 minus 7 the whole squared plus minus 1 minus 2 the whole squared. This is equal to root of 2 minus 3 is equal to 5 squared plus 4 minus 7 is minus 3 the whole squared plus minus 1 minus 2 is again minus 3 the whole squared, which is equal to root of 5 squared is 25 plus 3 minus 3 the whole squared is 9 plus 9. Minus 3 the whole squared is 9. 9 plus 9 is 18. 18 means it is equal to root of 13. It is equal to root of 43. Root of 43. This is how you find the distance between two formulas. Root of x2 minus x1 the whole square plus y2 minus y1 the whole square plus z2 minus z1 the whole square. Now, next question. Take down the next question. Show that second question, show that the given points are collinear. What do you mean by collinear? That means the three given points lie on the same straight line. A, B, C. A, B, C lie on the same straight line. This is called as collinear. Collinear. Now, we have to show that the 3 points are collinear. What are the 3 points? Minus 2, 3, 5, 1, 2, 3, 7, 0, minus 1. Now, how can you show that the 3 points are collinear? Now, if you want to show that the 3 points are collinear, make use of the distance formula. Now, let us mark these points as A, B and C. Find the distance AB. Only for one, I am writing the formula. It is equal to root of x2 minus x1 the whole squared plus y2 minus y1 the whole squared plus z2 minus z1 the whole squared, and that is equal to root of 1 minus minus 2 the whole squared plus 2 minus 3 the whole squared plus 3 minus 5 the whole squared, which is equal to root of 3 squared plus minus 1 squared plus minus 2 the whole squared is equal to root of 9 plus 1 plus 4 is equal to root of 14. This is the distance of AB. Now find out the distance BC. Is equal to root of, formula is here, 7 minus 1 the whole squared plus 0 minus 2 the whole squared plus minus 1 minus 3 the whole squared equal to root of 6 squared plus minus 2 the whole squared plus minus 4 the whole squared equal to root of 36 plus 4 plus 16. 40 plus 16 is equal to root of 56. But you can see that if you want, you can convert root of 14 into a decimal number and root of 56 into a decimal number. Or you can say that root of 56 2 28 times 2 14 times. So this is equal to 2 root 14. Now AC is equal to root of 7 minus 2 the whole square plus 0 minus 3 the whole square plus minus 1 minus 5 the whole squared is equal to root of 9 squared plus minus 3 the whole square plus minus 6 the whole square is equal to root of 81 plus 9 plus 36. 90 plus 36, 126. So as such you cannot find there is any relationship. Find out root of 126. 126, 263. 3, 2, 21. 3 sevens are 21. So this is equal to 3 root 14. 3 root 14. So you can get a relationship like AB plus BC gives you AC. That is root of 14 plus 2 root 14 is equal to 3 root 14. Now if it can be expressed in this form, that means therefore the 3 points are collinear. 3 points are collinear. One length of one side is expressed as the sum of other two sides. That means the 3 points are collinear. I hope you got this point. Lie on the same straight line. Collinear means the 3 points lie on the same straight line. Here AB plus BC is equal to AC. That means the 3 points are collinear. Next one. Verify the following. Zero, 7, minus 10. Let us take this as A, B. 1, 6, minus 6, C. 4, 9, minus 6 are the vertices of an isosceles triangle. Now, what do you mean by an isosceles triangle? An isosceles triangle means length of two sides are equal. Length of any two sides are equal. That is, you have to find out the length of AB, BC and AC, and you have to show that the length of out of three sides, two sides are equal. So let us consider this length AB equal to root of, first write the formula, x2 minus x1 the whole squared plus y2 minus y1 the whole squared plus z2 minus z1 the whole squared is equal to root of A and B. 1 minus 0 the whole squared plus 6 minus 7 the whole squared plus minus 6 minus 10 the whole squared is equal to root of 1 squared plus minus 1 squared plus 4 squared equal to root of 1 plus 1 plus 16 is equal to root of 18. Length of AB is equal to 18. Find length of BC. BC is equal to root of 4 minus 1 the whole squared plus 9 minus 6 the whole squared plus minus 6 minus 6 the whole squared is equal to root of 3 squared plus 3 squared plus 0 squared is equal to root of 9 plus 9 is equal to root of 18. Now you have got two sides are equal, but you find out the third side also. AC is equal to root of 4 minus 0 the whole square plus 9 minus 7 the whole square plus minus 6 minus 10 the whole squared equal to root of 4 squared plus 2 squared plus 4 squared, that is equal to root of 16 plus 4 plus 16 is equal to root of 36 is equal to 6. So in this case we can say that length of AB is equal to length of BC. AB is equal to BC. So triangle ABC is an isosceles triangle. Is an isosceles triangle since length of two sides are equal. It is an isosceles triangle. Now, suppose if you want to show that the triangle is a right triangle, right-angled triangle, you find the length of, suppose the vertices are A, B and C. Find out the length of AB, BC and AC. You can find a relation as the Pythagoras theorem, that is hypotenuse squared is equal to base squared plus altitude squared. If you can express in this form, then that means that is you are finding the distance AB, BC, AC. Anything can be hypotenuse, base and altitude. If hypotenuse squared is equal to base squared plus altitude square, that means that triangle is a right-angled triangle. Now, what about for a parallelogram? For a parallelogram, opposite sides are equal in length. Opposite sides are equal in length. Next one, section formula. Now, suppose there is a point. Suppose there are 2 points A and B. X1, Y1, Z1 and x2, y2, z2. Now a point P divides the join of A and B in the ratio m is to n internally. M is to n internally. That means the join of A and B is divided into two parts in the ratio m is to n. So what is the coordinate of P? The coordinate of P is given by m x2 plus n x1 by m plus n. This is the x coordinate, m x2 plus n x1 by m plus n. What will be the y coordinate? M y2 plus n y1 by m plus n, and m z2 plus n z1 by m plus n. Now, if the point P lies outside, that is, if the division is an external division, then what about the point P? It is mx2 minus nx1 by m minus n, my2 minus ny1 by m minus n, mz2 minus nz1 by m minus n. If the division is an external division, this is how you get the coordinate. Next one, you have the midpoint formula. Internal division, external division. Next one is the midpoint formula. Suppose this point P, A, B, P divides in the ratio 1:1, because it is the midpoint. P is the midpoint of A and B. That is, this one is x1, y1, z1. This is x2, y2, z2. So what are the coordinates of P? The coordinates of P is x2 plus x1 by 2, y2 plus y1 by 2, and z2 plus z1 by 2. Now, suppose you have to know about the centroid of the triangle. Now, let us consider a triangle ABC. x1, y1, z1, x2, y2, z2, C, x3, y3, z3. Now from A, you draw the median, that is to the opposite midpoint of the opposite side, BC. Median. AD is a median. BE is another median. And CF is another median. That is from the vertex to the midpoint of the opposite side. that is called as a median. So there are three medians, AD, BE and CE. They are the medians. AD, BE and CF are the medians. The meeting point meeting point of the medians is called the centroid of the triangle. Centroid, it is denoted by the letter G. Centroid G. And this property of the centroid is, it will be dividing the median in the ratio 2:1. 2 towards the vertex and 1 towards the opposite side. So, what about the coordinate of D? Because it is a midpoint, the coordinate of D will be x2 plus x3 by 2, y2 plus y3 by 2, and z2 plus z3 by 2. I am giving this as an assignment. So, what about the median? Median from the vertex to the opposite midpoint of the opposite side, the line segment, that is called as a median, and the meeting point of the median is called as a centroid. The centroid divides a median in the ratio 2:1, that is 2 towards the vertex and 1 towards the opposite side. Now, we can show that the coordinate of the centroid G, it will be in the form, x coordinate will be x1 plus x2 plus x3 by 3, y1 plus y2 plus y3 by 3, z1 plus z2 plus z3 divided by 3. Now, this I am giving you as an assignment question, because by making use of the internal formula, section formula, internal division 2:1, you know the coordinate of A, x1, y1, z1. You know the coordinate of D, because D is the midpoint of BC. You know, you can make use of the section formula, x2 plus mx2 plus nx1 by m plus n, my2 plus ny1 by m plus n, mz2 plus mz1 by m plus n. In the same way, m and n are 2 and 1. You can make use of the formula and you can derive the centroid. The coordinate of the centroid of the triangle is G is x1 plus x2 plus x3 by 3, y1 plus y2 plus y3 by 3, and z1 plus z2 plus z3 by 3. So, complete this section formula as an assignment question. I hope everything is clear to you regarding the octants, 8 octants, the sign of the sign of each point in the quadrant in the octants. It is very, very important. Is this not clear to you? Centroid. Centroid of the triangle. Meeting point of the medians is called the centroid of the triangle. Okay. So, thank you.